Tick-tock, tick-tock, the steady rhythm of a clock echoes through our lives, marking the passage of time. But what if everything we thought we knew about time was wrong? Prepare to have your mind blown as we dive into the mind-bending world of modern physics and challenge our most fundamental assumptions about reality. Picture this, a mesmerizing montage of clocks, calendars, and time-lapse footage flashes before your eyes. The familiar flow of seconds, minutes, and hours seems so constant, so reliable. Yet, beneath the surface of our everyday experience lies a startling truth. Time, as we know it, might be nothing more than an illusion. Enter Dr. Carlo Rovelli, a theoretical physicist at the forefront of loop quantum gravity. His groundbreaking research suggests that time may not exist as a fundamental property of the universe. Let that sink in for a moment. The very fabric of reality might not include time as we understand it. As Rovelli puts it, the equations of physics do not tell us which events are occurring right now. Mind-boggling, isn't it? But wait, there's more. Let's take a journey into Einstein's world of warp time. Special relativity tells us that time isn't a constant, it actually slows down at high speeds. This isn't just theoretical mumbo-jumbo, it has real-world implications. Did you know that GPS satellites have to correct for time differences due to gravity? That's right, time passes differently in orbit than it does on Earth's surface. Now, imagine standing at the edge of a black hole. As you approach its immense gravitational pull, time itself begins to bend and stretch like a piece of cosmic taffy. General relativity shows us that time can be warped by massive objects, creating a mind-bending dance of space-time. Even here on Earth, time ticks by ever so slightly faster at the top of a mountain than it does at sea level. The universe is far stranger than we ever imagined. But hold on to your hats because things are about to get even weirder. Welcome to the bizarre realm of quantum mechanics, where time itself seems to vanish into thin air. The Wheeler-DeWitt equation, a cornerstone of quantum gravity, does something truly extraordinary. It completely omits time from its calculations. It's as if the fundamental building blocks of reality don't need time to exist or interact. Quantum entanglement takes this temporal confusion to a whole new level. Particles can be instantaneously connected across vast distances, seemingly ignoring the very concept of now. As we zoom into the quantum scale, we find a world where cause and effect blur, and the arrow of time loses its sharp point. Speaking of arrows, let's talk about entropy and the flow of time. Why do we see eggs break but never unbreak? Why do we remember the past but not the future? The answer lies in the laws of thermodynamics and the concept of entropy. As systems naturally tend towards disorder, we perceive a direction to time's flow. But here as the kicker, this arrow of time is more of a statistical tendency than a fundamental law of nature. So, if time isn't what we thought it was, how do we experience it so vividly? The answer might lie within our own minds. Neuroscience reveals that our brains are master illusionists, weaving together memories and sensory inputs to create a seamless tapestry of past, present, and future. We're hardwired to perceive time as a continuous flow, organizing events into before and after. It's a survival mechanism, allowing us to learn from the past and anticipate the future. But what does all this mean for our understanding of reality and our place in it? Philosophers like Julian Barber and Christy Miller have grappled with these questions for years. If time doesn't fundamentally exist, what happens to concepts like free will and causality? Can we truly make choices in a timeless universe? These aren't just abstract musings, they strike at the heart of what it means to be human. Imagine a world without time, no deadlines, no aging, no regrets about the past or anxiety about the future. It's a concept that's both liberating and terrifying. But before you throw away your watch and calendar, remember that even if time isn't fundamental to the universe, it's still fundamental to our lives. We may live in a timeless cosmos, but our human experience is deeply rooted in the passage of time. We wake up, go to work, celebrate birthdays, and mourn losses, all within the framework of time. Science may challenge our assumptions, but it doesn't negate the practical importance of time in our daily lives. So, where does this leave us, standing at the intersection of mind-bending physics and everyday reality? Time may be an illusion, a construct of our minds rather than a fundamental aspect of the universe. But it's an illusion we live by, one that shapes our experiences, our memories, and our very sense of self. The next time you glance at a clock or make plans for the future, take a moment to marvel at the complexity hidden beneath the surface. Time may not be what we thought it was, but it remains one of the most fascinating and mysterious aspects of our existence. In a universe full of wonders, the nature of time might just be the greatest wonder of all. As we wrap up this mind-bending journey through the nature of time, remember, the universe is far stranger and more wonderful than we ever imagined. The next time someone asks you for the time, you might just want to reply, "It's all relative." After all, in a timeless universe, being fashionably late takes on a whole new meaning.